Skewness. We all know that skewness of a distribution refers to its asymmetry. In this lesson, we will discuss skewness and measures of skewness. After going through this presentation, you should be able to explain meaning of skewness, define positive skewness, and describe negative skewness and discuss the measures of skewness. The skewness may be either positive or negative. The lack of symmetry in a distribution is always determined with reference to a normal or Gaussian distribution. When the skewness of a distribution is positive, the distribution is called a positively skewed distribution. Absence of skewness makes a distribution symmetrical. It is important to emphasize that skewness of a distribution cannot be determined simply by inspection. Skewness is defined as the departure from symmetry. When mean is greater than mode, the skewness is positive. If mean is less than mode, the skewness is negative. If mean equals to mode, the skewness is zero. Positive skewness results if some observations of higher magnitudes are added to a symmetrical distribution so that the right-hand tail of frequency curve gets elongated. Negative skewness results when some observations of low magnitudes are added to the distribution so that the left-hand tail of frequency curves elongated, as shown in the figure. The absolute skewness is measured by the difference between mean and mode. Such measure would not be meaningful because it depends on the units of measurement. They may tail off to the right or to the left and as such said to be skewed. The simplest measure of skewness is the Pearson's coefficient of skewness, which equals to mean minus mode divided by standard deviation. A measure of skewness gives the extent and the direction of skewness of a distribution. Pearson's coefficient of skewness is based on mean, mode, and standard deviation. And second is Bowley's coefficient of skewness, which is based on quartiles and percentiles as depicted in the formula, whereas it will lie between -1 and +1. Q1 is first quartile and Q3 is third quartile. ME is mode. If the second and third moments about the mean of a distribution are mu2 and mu3 respectively, then moment-based coefficient of skewness equals to mu3 to the power 2 divided by mu2 to the power 3. It is invariant under the change of scale and change of origin. Now let us check if we have understood the various concepts discussed in this lesson clearly. A measure of skewness based on quartile is given by Bowley's. Right or wrong? Right. In a symmetrical distribution, mean, median, and mode are unequal. Right or wrong? Wrong. The degree of skewness in a distribution can be measured both in the absolute and relative sense. Right or wrong? Right. Before we end, let us briefly revise what we have studied so far. Skewness of a distribution refers to its asymmetry. Positive skewness results if some observations of high magnitudes are added to a symmetrical distribution so that the right-hand tail of frequency curves gets elongated. The simplest measure of skewness is the Pearson's coefficient of skewness, which equals to mean minus mode divided by standard deviation. Bowley's coefficient of skewness is based on quartiles and percentiles, whereas it lies between -1 and +1. Q1 is first quartile and Q3 is third quartile, while MD is mode.